Welcome to The Explainer. So, how on earth do you measure something you can't see or touch? Things like creativity, or job satisfaction, or even burnout. It might sound impossible, right? Well, as we're about to see, it's not only possible, it's something we absolutely have to get right. Okay, let's just dive right into it. Because whether you realize it or not, we are constantly measuring things and being measured ourselves. Think about it. Schools grade our knowledge, employers test our potential. Measurement is happening all around us, all the time. And the stakes here, they are incredibly high. I mean, if we don't have reliable and valid ways to measure these abstract ideas, the decisions we make based on them, like who gets hired, which program gets funded, or what business strategy to follow, can be completely unjustified. And that can really negatively affect people's lives. So here's our game plan for this explainer. We're going to start by defining what it even means to measure the invisible. Then we'll look at the 4 scientific rulers that we use for the job. After that, we'll see how you actually build a better one. And finally, how to make sure it's both consistent and accurate.
All right, first things first. Before we can measure the invisible, we have to agree on what measurement actually is. And, the scientific definition is probably a little more specific than you think.
And here is the absolute key. We're not measuring the whole person or the whole object. We're measuring a specific attribute, like someone's knowledge, not the person themselves. And this has to be done with a clear, standardized set of rules so that everyone measures the exact same thing in the exact same way. And following these rules, it's a total game changer. It replaces subjective gut feelings with real objectivity because the rules are out in the open and they're consistent. It gives us numbers we can actually analyze with powerful statistical tools, and maybe most importantly, it creates a common language so that everyone can build on each other's work, making the whole process way more efficient and powerful.
But not all measurement is created equal. You should think of it like having 4 different kinds of rulers in your toolkit. Each one is a little more powerful and a little more precise than the one before it. These are the nominal, ordinal, interval, and ratio scales. They actually build on one another, and the type of ruler you choose completely determines what you can say about the thing you're measuring, and even what kind of math you can do with the numbers you get.
Okay, so the most basic ruler is the nominal scale. It doesn't really measure so much as it just sorts things into different buckets. The numbers are just labels. So giving 1 to US residents and 2 to Canadian residents doesn't mean anything about value, it's just a way to classify. All this scale can tell you is if things are different. That's it. Next up, we have the ordinal scale, and this one adds rank order. So if Maria is ranked 2 and Bob is 1, we know she's a higher performer. But here's the catch. We don't know how much higher. The gap between the ranks is a complete mystery. Is she just a little bit better, or is she a total superstar? This ruler can put things in order, but the space between the marks is totally unknown. The interval scale is a major upgrade because now our ruler has consistent equal spacing. The difference between 10 and 20 degrees Celsius is the exact same as the difference between 30 and 40 degrees. But the 0 point is arbitrary. 0 degrees Celsius is just the freezing point of water. It's not the absence of all heat. So you can't say 20 degrees is twice as hot as 10 degrees. And finally, we have the ratio scale. This is the most powerful one. It has everything the others do, plus a true absolute 0. A weight of 0 literally means no weight. This is the only scale that lets us make those ratio statements, the only one that lets us say something is twice as tall or has half the weight. It's really our gold standard ruler.
Okay, so we've got our types of rulers. But how do researchers actually build a new measurement tool? Like a new survey for employee burnout or a test for creativity from scratch? Well, it's a super deliberate and systematic process. And the process is incredibly rigorous. First, you have to precisely define what you're measuring. If you can't define creativity clearly, you have no chance of measuring it. Second, you build a blueprint, deciding on the format and the type of scale. Third, and this is interesting, you write way more questions than you need, often double, because a lot of them just won't make the cut. Fourth, you do a pilot study, a crucial trial run where you test those questions on a representative group. And then finally, you analyze all that data to keep only the strongest, most effective questions. A key part of that analysis is checking how well each individual question lines up with the total score. Think of it like you're building a sports team. You want players, or in this case questions, that actually help the team's overall score. A question with a high correlation, like item 2 here, that's your star player. It does a fantastic job of telling the difference between people who score high and low overall. But a question with a low correlation, like item 1, it's just not pulling its weight, and it gets dropped from the team. All right, now for what is maybe the most critical part of all, quality control. Once you've built your measure, you have to prove that it's actually any good. A measurement tool is absolutely useless if it isn't both reliable and valid. These two concepts are the cornerstones of all good measurement. And the key is telling them apart. Reliability is just consistency. If you step on a bathroom scale 3 times, do you get the same weight each time? That's reliability. Validity, on the other hand, is accuracy. Does the scale show your true weight? A scale can be reliably wrong, telling you you're 5 pounds heavier every single time. And remember this, a measure can be reliable without being valid, but it can never be valid unless it is reliable first. So to prove a measure is reliable, researchers run a bunch of different tests. They're all designed to answer one question from different angles. Is this result dependable, or is it just random noise? And that noise could be anything, a person's mood, a weird sound in the room, a confusing question. These tests check for score stability over time, consistency across different versions of the test, and even agreement between different human judges. Now, for validity, the evidence has to show that the measure is truly accurate. Does it cover the entire concept, or is it missing something important? Can it predict a real-world outcome, like whether a skills test actually predicts future job performance? Does it fit with existing scientific theories? This isn't a single check. It's like building a comprehensive case file to prove you're truly measuring what you claim you are. So why? Why go through all this trouble? Why this intense, multi-step process of defining, building, testing, and verifying? Because this level of rigor is what allows us to truly and confidently understand the world around us. A number like this, 0.92, is a reliability score. It's basically a measure of confidence. It tells us that 92% of the difference we see in scores reflects real differences between people, and only a tiny 8% is random error. It means we can trust the results. When a company uses a test with this level of reliability, they can be confident that they're making decisions based on real information, not just statistical ghosts. And ultimately, that really is the point. Good measurement is the absolute bedrock of science and of making informed decisions. It's what allows us to move beyond just subjective guesses and gut feelings to an objective, evidence-based understanding of things. Without it, real progress is simply not possible. So, the real takeaway here is a brand new lens for viewing the world. The next time you see a study, a ranking, or even a personality quiz, ask yourself that critical question. How did they measure that? Is it reliable? Is it valid? Because now you know that is what truly matters. Which kind of makes you wonder, what's one thing in your world that really deserves a better measure?